Ladies and gentlemen, I want us to have a look at this question. And this question is from the topic of differentiation, and specifically, it is from stationary points. The question is identify the stationary point on the curve y equals to x cubed minus 3x plus 2. Full stop. Determine the nature of each stationary point. It tells us to determine the nature of each stationary point. So the first thing is to identify the stationary points. Then after identifying them, we determine their nature. Now, the first thing that we shall do in this is to find the gradient function. Then after obtaining the gradient function, as we know that at stationary points, the gradient function or the gradient is 0. Therefore, we equate the gradient function with 0 to obtain the value of, that is to obtain the value of x. And after obtaining the value of x, we substitute the value of x that we have obtained in our original function of y. This is the original function or the original equation of the curve. This is the equation of the curve that we have. So after obtaining the value of x, then we substitute in this to obtain, that is, the value of y, so that we get to know the stationary points from there. Now, let us find the gradient function, that is dy over dx equals to, if we differentiate this function of y with respect to x, we shall differentiate each term in turn, and therefore in this, the first term is x cubed. So we shall bring x, that is 3, before the first term, and we multiply with the first term, that is 3 here. Then we multiply with the first term, then raise to 3, but we less the power by 1. Then close the bracket. The power of x here is 1, and therefore it will be minus 1 into, we have 3x raised to 1, but we less the power by 1. Then if we differentiate 2, that is positive 2, it is 0 because it is a constant. And therefore, the gradient function will be, this is 3, this is x raised to 3 minus 1 is 2. Therefore, it will be x raised to 2. Then minus, this is x raised to 1 minus 1 is 0. Therefore, x raised to 0 is 1. 1 times 3 is 3. Then 3 times negative 1 is negative 3. And this one is the gradient function. This one is the gradient function. Since this one is the gradient function, then we can say that at stationary points, our dy over dx is 0. Our dy over dx is 0 at stationary points. Therefore, since our dy over dx is this function, that is 3x squared minus 3, then we can equate it with 0 in order to obtain the value of x. Now we can divide here by 3 and here by 3 and here by 3, so that we have x squared, that is x squared minus 1 equals to 0. Now we need to expand this. We need to expand x squared minus 1. We need to expand so that we shall have, that is x minus 1 and also x plus 1. Then we equate it with 0. Because x squared minus 1 can be x minus 1, x plus 1. So in this case, that means x minus 1 is either 0 or that is x plus 1 is 0. Therefore, in this case, our value of x can be, when we take 1 to the other side, it will be positive 1. Or When we also take positive 1 to the other side, it will be negative 1, and therefore the value of x is either positive 1 or negative 1. Now, we need to obtain the value of x when x is 1 and also when x is negative 1. Now, when x is 1, what is our y? Our y will be, instead of x, we shall have 1. So it will be 1 cubed. 1 cubed minus 3 into 1, then plus 2. So we have substituted this value of x in our original equation. That is the equation of the curve. So this one will be y equals to, this is 1 cubed, which is 1, minus 3 times 1, it will be minus 3, then plus 2. And in this case, we shall have, that is y equals to, 1 minus 3 is negative 2, then plus 2 is 0. Plus 2 is 0. Therefore, our first stationary point will be x is 1, then our y will be 0. Our y is 0. Therefore, this is the first stationary point. Let us obtain the second stationary point when x is negative 1. When x is negative 1, our y will be, that is negative 1 cubed. This is, instead of x, negative 1. Negative 1 cubed minus 3 into negative 1, then plus 2. This is, I am substituting in our original equation of the curve. And in this case, we have y equals to, negative 1 cubed is negative 1. Then negative 3 times negative 1, it will be positive 3, then plus 2. In this case, we shall have our y as negative 1 plus 3 is 2, then plus 2 is 4. And therefore, the value of y is 4. And therefore, the second point, the second stationary point is when x is negative 1, our y is 4. That is the second stationary point. Now, we need to find, or we need to determine the nature of these stationary points. We need to determine their nature. We need to determine the nature of each stationary point. This is the first point, this is the second. Now, in our first point, where we have the coordinates as 1 and 0, we shall have this table. We shall have this table. That is the value of x, dy over dx. This is the gradient. Then we have the sign, whether the sign of the gradient is positive or negative or 0, and the diagrammatic representation. Now, we have the gradient function. So the first value of x that we have to consider is this, which is 1, and we shall put it at the center here, so that we find a value that is to the left of 1. The value that is to the left is 0, and the value that is to the right of 1 is 2. Now, since we have that, we need to obtain dy over dx, but we have the gradient function, which is 3x squared minus 3. Therefore, our dy over dx will be, instead of, that is x, we shall have 0. So it will be 3 times, when we substitute 0 here, it will take this one to 0, and therefore we have negative 3. And if we substitute here 1, it will be 3 into 1 squared. 1 squared is 1, times 3 is 3. Minus 3, this one is 0. But remember that the gradient, this is the gradient, that is dy over dx. At this point, this is a stationary, remember this one is from a stationary point. The gradient at a stationary point is always 0. Therefore, even if you have not substituted here, it is always 0. Now, when x is 2, what is dy over dx? So it will be 3 into 2 squared. 2 squared is 4. 4 times 3, 12. 12 minus 3. 12 minus 3 is 9. And therefore, the sign of the gradient at this point, it is negative. At this point, it is 0. At this point, it is positive. Now, that means the diagrammatic representation will be negative, 0, and positive. Therefore, this one is a minimum point. This one is a minimum point. Therefore, we can say that the point that is the point 1, 0 is a minimum point. It is a minimum point. It is a minimum point. That is a minimum point. That is the nature of the first point. Now, let us have a look at the second point. Let us have a look at the second point and determine whether it is a maximum, a minimum, or a point of inflection. Now, in the first point, we shall take this negative 1 and put it at the center here, so that, and that is a value that is to the left of negative 1 is negative 2. Then a value that is to the right is 0. So at stationary point, that is the stationary point is negative 1, 4. Negative 1, 4. So this one will be 0. dy over dx is 0, because if we substitute this negative 1 here, it will be 3 into negative 1 squared, which is negative 1 squared is 1 times 3 is 3, minus 3 is 0. And when x is 0, what is dy over dx? It will be 3 into 0 squared minus 3, which is just negative 3. Then when x is negative 2, we shall have negative 2 squared, which is negative 2 squared is 4 times 3 is 12, minus 3, it is 9. Now in this case, the sign at this point, it is positive because we have positive 9. This point is 0. Then at this point, it is negative. Therefore, the diagrammatic representation, it will be positive, 0, negative. Therefore, this is a maximum point. We can say that a point that is the point 1, which is negative, 4, is a maximum point. It is a maximum point. It is a maximum point. That is the nature of the point negative 1, 4.